Over to you, ma'am.
Yeah, thank you, Monica. Good evening, students. This is Dr. Garima Agarwal from Manipal University, Jaipur. So, in our last lecture, we have discussed the partial differentiation, right? Let me revise it, then we'll move forward. So, in this unit, we'll discuss what is partial differentiation and what is total differentiation.
Ma'am, please share your screen if.
Oh, I'm sorry. That's okay.
Ma'am, PPTs are not visible. Now it's visible, ma'am.
Okay, fine. Thank you. So in last lecture we have discussed the partial differentiation and total differentiation. This is the formula for partial differentiation. This is second order partial differentiation. Now, then we have discussed few example based on partial differentiation. Then we have discussed the chain rule. These are the example based on the chain rule. Then implicit functions, differentiation of implicit function. Now today we'll discuss the exact differentiation or total differentiation. Through partial differentiation, how we can find the total differentiation or partial differentiation. Let's say we have a function let's say we have a function fxy. It is a function of two variables x and y, right? So rate of increase of fxy in x and y direction is del f by del x and del f by del y respectively. This is the definition of partial differentiation. Now rate of increase of fxy in both the directions is given by this formula, or we can write it in that form also. Here d is the rate of change, total rate of change d, and del denotes the rate of change in the direction of x and rate of change in the direction of y, right? So total rate of change is equals to pxy dx. This term can be known as pxy, that is function of xy, and del f by del y can be written as qxy, that is again function of xy. So by this formula we can find the total derivative through partial differentiation. Now this term can be said exact differential equation if partial differentiation of p with respect to y is equals to partial differentiation of q with respect to x. Clear? If it is exact, then it is integrable and independent of the path of integration, right? Here we have one example based on this exact differentiation. We need to find the total derivative for this function, right? So the formula for total derivative is del f by del x dx plus del f by del y dy, right? Here del f by del x, that means we need to find the value of del f by del x and del f by del y. Del f by del x means partial differentiation with respect to x, means y will be treated as constant. So in this term sin y is constant, partial differentiation of x cube is 3x square, y square is constant, partial differentiation of x is 1. Similarly del f by del y, I think there is some typo error, it should be y. So del f by del y, that means x cube is constant and differentiation of sin y is cos y. Then again x is constant and differentiation of y square is 2y, right? Then we substitute both the values here, we'll get this equation, right? After substituting the value of del f by del x and del f by del y. Now in now we need to find the exact differentiation of this function at the point 1 and 2, right? So what will be the formula? Again df is equals to del f by del x. The formula is df is equals to del f by del x dx plus del f by del y dy. This is the formula, right? So del f by del x is 2x and del f by del y is 2y. Now at the point 1 and 2, that means we need to substitute x is equals to 1 and y equals to 2. Similarly, find the exact differentiation for this function. So again we'll find del f by del x, del f by del y and substitute the value here. So the next is maximum value, minimum value and critical value and saddle point. What is the maximum value? Fxy is said to have the maximum value at the point P if f at AB is greater than all the values in the neighborhood of P. That is, function of AB is greater than function of f, function of a plus h, b plus k, right? And similarly minimum value, if the function has minimum value at that particular point and minimum value then all the values in the neighborhood, then it is known as minimum value. Then critical point, a point of the function is said to be critical or stationary point if partial differentiation of the function with respect to x and with respect to y at that particular point AB is 0, or if one or both the partial derivative does not exist. Then the saddle point, a point where function is neither maximum nor minimum, it is known as saddle points. Clear? Now how we can find the maxima and minima? First of all, we find del f by del x and del f by del y and equate it to 0. Solve these equations simultaneously for x and y to find the roots. By solving these two equations, we will find the roots. These points are called stationary points or critical points, means either will get maximum or minimum value at these points, right? Then we will find the second order partial derivative, that is r, t and s. These are the standard notations. We cannot denote r by some other notation, t by some other notation, right? R, S and T, all three are standard notations. Then we'll calculate RT minus S square for all the points. All the points means the points which we get by equating these two terms to 0. For all these points, we'll find RT minus S square, right? If RT minus S square is greater than 0, D, we denote it RT minus S square by D. This is not a standard notation, right? So if RT minus S square is greater than 0 and R is less than 0, then the pair of roots has maximum point. And if D is greater than 0, R is greater than 0, then the point is known as minimum point. If RT minus S square is less than 0, then the function is or the point is saddle point. If RT minus S square equals to 0, then the case of undecided and further investigation is required, right? So these 4 points we need to remember. If RT minus S square is greater than 0, R is less than 0, then the point is maximum. If RT minus S square is greater than 0, R is greater than 0, then the point is minimum. If RT minus S square is less than 0, then saddle. If RT minus S square is equals to 0, then further investigation required, right? So we need to recall these 4 points. Clear? Let's discuss few example based on maxima and minima. Here we have this function and we need to find the maxima and minima, right? So first of all, we'll find del f by del x, del f by del y, and RST. Del f by del x, del f by del y. This is the value of R. This is the value of t, and this is the value of s. Right? Then we'll equate these two terms to 0. That means 2x minus 2 equals to 0 and 2y minus 6 equals to 0. So by this equation, x is equals to 1, and by this equation, y is equals to 3. So that should be y. Right? So these are x equals to 1 and y equals to 3. This is the point on which we need to find whether the function is maximum or minimum. So we find R, S, T at the point 1 and 3. We'll already calculated the R, that is 2, T is 2, and S is 2. So R, S and T. Now RT minus S square is 4, which is greater than 0, and the value of 2 is again greater than 0. So if RT minus S square is greater than 0, R is greater than 0 at certain point 1 and 3, then the function is minimum. Clear? Here we have one more example to discuss the maxima and minima. This is the function. So first of all, what we'll do, we'll find del f by del x, del f by del y, del 2f by del x2, del 2f by del y2, del 2f by del x del y. Then we'll equate these two terms to 0, right? And after simplification, we get the value of x and y as x equals to 0, y equals to 0, and x is equals to y. But if x and y both equals to 0, it does not hold for 1 and 2. If I substitute x equals to 0, y equals to 0, it will be infinity, right? If denominator is 0, that value cannot exist. So the roots of this equation is x is equals to y. If I substitute x equals to y in equation 1, I get the value of x, that is x cube equals to a cube, or x equals to a. Similarly, it is for y, right? So x equals to a, y equals to a, these are the points. Then we find R, S, T and RT minus S square at the point x equals to a and y equals to a. So RT minus S square is 3, which is greater than 0. R is greater than 0, that means function is minimum. And what is the minimum value? Function is minimum at a point. But what is the minimum value? We'll substitute a in this function. F a will be a plus a cube by a plus a cube by a. Or we can write it as a square plus a square plus a square, or 3a square. If there is any doubt in maxima minima, please let me know. Please raise your hand. No? If any doubt in exact differential equation, then also please raise your hand. Okay, fine. So now let's move towards the next topic, that is Lagrange's method of undetermined multipliers. It is a method to find the extreme values of the function for more than one variable with any constraint or restrictions, right? If we have a function of a function which is having more than one variable, and also we have one restriction or constraint, then how we can find the maximum or minima? It is given by Lagrange's method. The drawback, we have one drawback from this method. We cannot find whether the function is maximum or minimum through this Lagrange's multiplier method. We can find that the function has extreme values at that point, but that extreme value is maximum or minimum, that we cannot find from Lagrange's method. This is the major drawback of this method. So what is the working rule to find the extreme values by Lagrange's method? First of all, the given function, just let given function as u or by any notation and equate it to 0. This is the condition. Then find del f by del x, del f by del y, del f by del z, equate it to 0. Differentiating 1, we get del f is equals to 0. This is del f. Then we find the differentiation of the second equation, that is the condition. Then we substitute function, this one is the function, plus lambda into condition, right? This equation is called Lagrange's multiplier equation, right? Then we simplify this term by collecting the coefficient of dx, dy and dz. Then we equate these term, I mean coefficient of dx, dy and dz separately, equating them to 0, and find the value of x, y, z and lambda, for which the function is maximum or minimum. So maybe you didn't get the theory. So let's discuss this Lagrange's method through this example. This is the function x square plus y square is equals to 0, and this is the condition, right? So always remember, we need to write function plus lambda times condition, right? So first of all, del f by del x plus lambda del g by del x equals to 0. Del f by del x is 2x, these two terms will 0. Del f by del g by del x is y plus z. Similarly, del f by del y plus lambda del g by del y, then del f by del z plus lambda del g by del z. Multiply equation 1 by x, equation 2 by y and equation 3 by z, and add these three terms, right? So it will be converted into this part. Now this x square plus y square plus z square is the function itself, right? So I can write it as f, and xy plus yz plus zx is p, so I can write it as p, right? And the value of lambda is minus f by p. So if we substitute the value of lambda in this equation 1, 2, and 3, we'll get these three equations, right? And after simplification of these three equations, we can find that P by Q is equals to minus 2 and X is equals to Y and Y equals to Z. So therefore, this function and this condition is maximum, but implies 3x square is equals to P and x square is equals to P by 3. This is the second example based on Lagrange's method. This is the function, or this is our function again, and this is the condition, right? So function plus lambda into condition is equals to 0, right? Then we find these three terms and equate it to 0, and we get the value of lambda by equating it to 0. Value of lambda is minus f. Then by substituting the value of lambda, we can find whether the function is at what point the function is whether maximum or minimum. Clear? If you guys are having any problem related to Lagrange's method, please raise your hand. No? Fine. The next is Jacobi method. So through Jacobi method, we can find inverse of the function, transformation of variables from one coordinate system to another coordinate system can be possible by Jacobi method. For example, changing from Cartesian coordinate to polar coordinate, polar to spherical coordinate, etc. Area and volume from surface and volume integral, that could be possible by Jacobi method. How we can use it, what is the definition and what is the formula? Let's say we have a function u of two variables x and y. Similarly, v is a function of two variables x and y, right? Then the Jacobi of u and v with respect to x and y is the determinant in this form. Determinant del u by del x, del u by del y, del v by del x, del v by del y, and it is denoted by del u v upon del x y or j u v, right? This is the Jacobi. And the Jacobi for three independent variable. How we can find Jacobi for three independent variable? Let's say we have a function u having three variable x, y, z, v, again having same three variables, and w with three variables. Then what will be the Jacobi? Del u by del x, del u by del y, del u by del z, del v by del x, del v by del y, del v by del z, del w by del x, del w by del y, or del u v w upon del x, y, z. This is the notation of Jacobi for three variables. Now this is for n variables. If u is function of n variable, u2 is function of n variable, and un is function of n variable, then we can denote it by this determinant, which is known as Jacobian. Now we have few properties on Jacobians. If u and v are function of two variables, then del Jacobi, then Jacobi del uv upon del xy times del xy upon del uv is 1, right? That is known as conjugate Jacobi, J prime, right? Then property 2, again if u and v are function of x and y, and x and y are again function of p and q, then we can write the Jacobi in this form, right? This is basically the chain rule that we have discussed earlier. If u, v, w are three independent variable and x, y, z are not independent, then del u, v, w upon del x, y, z is equals to 0. And by the property 4, if u and v are implicit functions of of x and y, then f1 u v x y is 0 and f2 is 0, then this one is the Jacobi for implicit functions. Clear? Here we need to find the Jacobi. These are few examples based on Jacobi. We have the value of u and v, and we need to find the Jacobi for this function, right? So this is the formula. Simply we need to substitute the values of del u by del x, del u by del y, del v by del x, del v by del y, and calculate this determinant. I hope you remember how we can find this determinant. 3 into minus 3 minus 4 into 5, that is minus 29, right? This is one more example for Jacobi for three variables. U is function of three variable x, y, z. V and w are also function of three variables. You can see that v is function of y and z, but x is not there. So 1 is written as x raised to 0 now. That means it is also function of x, right? We can consider 1 as constant as well as function of x as well as function of any variable, right? Now this is the formula, just substitute all the partial derivatives and find the determinant. Then the chain rule, u is function of x, y, z, v is function of x, y, z, w is function of x, y, z. So here Jacobi of u, v, w times Jacobi of x, y, z is equals to 1. So Jacobi of u, v, w, we just calculate here Jacobi of u, v, w. Then we calculate the Jacobi of x, y, z, and if we multiply both the terms, it will be equals to 1, right? Here also it is the example of implicit function. This is implicit function, right? F1 and F2 are implicit functions. So first of all, Jacobi for F1 and F2 is calculated here with respect to x and y. Then Jacobi of F1, F2 with respect to u and v is calculated here. Then we find the Jacobi for uv by chain rule. Clear? Okay. Next topic is double integration. So before moving towards the double integration, if you guys are having any doubt in homogeneous equations, no, sorry, exact equations, maxima, minima, and Jacobi, please let me know. Yeah. Yes, Tarpita, please unmute yourself and you can ask your question. Tarpita, please unmute yourself first.
Yes, ma'am. Can you please explain the properties of Jacobian again, please?
Jacobi.
Yeah.
So the first property is, let's say u and v are function of two variables x and y, right? So Jacobi of uv times Jacobi of xy is equals to 1. Here you can see that this is the cross multiplication. I can if you cancel these term, it will be 1, right? So the first property is Jacobi of uv. This term is known as Jacobi of uv, and this term is known as Jacobi of xy is equals to 1. If u is function of xy, v is function of xy, then Jacobi of uv times Jacobi of xy is equals to 1. That we have discussed in one example as well, right? Yes.
Yeah.
In the second property, if u and v are function of x and x and y are again function of p and q, then the Jacobi will be Jacobi of uv with respect to p and q is Jacobi of uv time with respect to xy times Jacobi of xy with respect to p and q. This is one is clear?
Yeah.
Because uv is function of xy. So first of all, we find Jacobi of uv with respect to xy. Then xy is function of pq. So we find Jacobi of xy with respect to pq. And the
Okay.
third property is if u, v, w are three variables with respect to x, y, and z. So Jacobi is this one. This one is just the extension of property 1. Property 1 is for two variables and this one is for three variables, right? Now the third, I mean fourth property is if u and v are implicit functions and x, y are dependent variables, like the first function is u v x y equals to 0. This one is implicit function. F2 is u v x y equals to 0. This one is also implicit function. We have also discussed this example based on implicit function, the last example. I'll again discuss the example based on implicit function. So Jacobi of uv with respect to xy is minus 1 whole square Jacobi of f1 f2 with respect to xy upon Jacobi of f1 f2 with respect to uv. Clear?
Okay.
So
Yeah.
let me discuss this implicit example again. Here u cube plus v cube is equals to x plus y. So the first function f1 is u cube plus v cube minus x minus y. I just shift x and y in the left hand side. So it will be minus x minus y. Then the second function is u square plus v square minus x cube minus y cube, right? Then this one is the formula. There minus 1 whole square is also there, but minus 1 whole square is 1 only, so no need to write it, right? So I just found the denominator and numerator and substitute the value over there. Right? Any other query? No? Fine. Now let's discuss the double and triple integration. It is one of the most important topic of our syllabus, and you need to understand this topic. Don't try to learn anything. Being a mathematician, I don't uh, uh, learn anything in double and triple integration except the standard formula of integration. You need not to learn anything. You need to understand. If you try to learn, you will not be able to solve a single question. Keep this thing in your mind. Everything is well defined in your question. It is the one of the most simple concept, but a student make it complicated at their end, right? So no need to learn anything except the standard formula of integration. Everything is well defined and everything is given in your question. The only thing you need to understand, and you need to find out what is the requirement and how you can fulfill your requirement through question, right? So basically, again, integration is what here we are discussing double integration. That means we are dealing with two variables x and y, right? If we divide this circle into small rectangles, this line is denoted by dx and this line is denoted by dy. Clear? If we add all these rectangle, we'll get the integration. Clear? Now there is no formula. No formula is required, right? So I'll start with this question. We need to find the double integration of sine y with respect to x and y, dx and dy. Here we'll use two terms, dx and dy, and we'll use two sign of integrations. Clear? There is no confusion. Then let me write here. This first of all we need to find the integration of this term, right? So integration of sine y is minus cos y. This is the standard formula. 0 to x and 0 to pi dx will be, right? Then 0 to pi upper limit, that is minus cos x, minus lower limit minus minus plus cos 0 dx. Then 0 to pi minus cos x, and the value of cos 0 is 1. Then differentiation of cos x is sin x, and integration of cos x is sin x, and integration of 1 is x under the limit 0 to pi. Now it will be minus of sin pi minus sin 0 plus pi minus 0, right? So sin pi is 0, sin 0 is 0, plus pi minus 0. So in total it is pi only. Any confusion? I'll ask uh, after every question. Yes, Raju Prasad. Please unmute yourself, Raju Prasad, and ask your question. Please quickly.
Hello.
Yes. Yes, Raju. I'm not able to hear you. Can you please? Hello.
Hello.
Yes, Raju.
Hello. Actually, ma'am, I have one related to beta and gamma function related. So can I ask right now or after some time?
No, I'm not discussing beta and gamma function, and I don't want to create a chaos in my class. So you need to understand whatever topic I am discussing, please ask the question related to that particular topic. Yeah. So this one is the next question, which is a bit complicated to the previous one. What is the question? We need to evaluate this integration, right? But the limit is not given. In the previous question, limit is given, so we need not to do anything. We just need to integrate this, integral. In this question, limits are given, but in the next question, limits are not given. What is given? The area between y equals to x square and y equals to x. You need to find out the limit, right? So what I'll do, first of all, I draw this y equals to x square. It is a parabola, right? Then I draw y equals to x line. This is the y equals to x line. Clear? What is the question? Evaluate this integral over the area between these two curves. So the area between these two curves is this region, right? Let me draw it again. This parabola will go through origin, right? This is the parabola and this is the line. Again, this line will go. Yeah. So this region is, this bounded region is given. We need to find the integral in this bounded region. But again, my problem is I need to find the limit. I don't want the region, I want the limit. How I can find the limit? One more thing before finding the limit, you need to decide which variable you want to take first. Like you want to integrate first with respect to y or with respect to x. Let's say I decide that I want to integrate first with respect to y. You can decide it, right? You can also integrate this term with respect to x first, right? So let's start with this. I want to integrate with respect to y first, right? That I have decided. So I kept this thing in a square bracket, the function dy and this integral. That means I need to write the limit of y. So what I'll do, I draw a parallel, a strip which is parallel to y-axis, because I have decided that I want to integrate first with respect to y. So I draw this parallel strip which is parallel to, I draw a strip which is parallel to this y-axis. This one is y-axis, right? Now this is this is the parabola whose equation is y equals to x square, and this one is the straight line y equals to x, right? This strip starts with the parabola and end at this line, right? That means the lower limit is the equation of the parabola, which is y equals to x square, and this strip at this line, that means the upper limit is x. Clear? Then find the intersection point. This point is origin 0, 0. The coordinate of this intersection point is y equals to x and y equals to x square. If I substitute y equals to x here, it will be x equals to x square, and it is x is equals to 1. That means this point is 1, 1, right? So now I want to find the limit of x. The limit of y I have already find out by drawing a parallel strip parallel to y-axis. This strip starts with the parabola, so the lower limit is the equation of parabola, and this strip ends at this straight line. That means the upper limit is the equation of line. Then I need to find the limit of x. For this, I first of all find the point of intersections, that is 0, 0 and 1, 1. The x coordinate of intersection point is 0 and the x coordinate of this intersection point is 1. So the limit of x is 0 to 1, right? This is the concept of limit, how we can find the limit. Then what I'll do, first of all, I'll integrate with respect to y. So x square will be constant. Integration of y is y square by 2. Then again x is constant, integration of y square is y cube by 3, limit is x square to x. X square to x is the limit of y. So I'll substitute the limit of y or y square or y cube, that is upper limit minus lower limit. Now the entire question is in one variable. We can easily integrate with respect to x and apply the limit. It is clear? Any doubt in this question? No? Pooja. Yes, Pooja. Please unmute yourself.
Yes, ma'am. Actually, ma'am, can you please repeat this diagram again? I mean, how you have, taken points.
So I need to explain this diagram or entire
Yeah,
question?
yeah.
Only
No,
diagram?
this diagram, yeah.
So let me delete this one first. I'll
Yeah.
draw it again. What is the equation of parabola? Y equals to 4ax square. This is the standard equation of parabola. If I take a equals to 1 by 4, it will convert into y equals to x square, right? This, you know what is parabola? This diagram is parabola, right? That is y equals to x square. If you want to explore more, please type on Google the equation of parabola or diagram or graph of parabola. You'll get the entire information about parabola. If you are from non-maths background, you can do this, right? Explore this term parabola through Google. So this is the diagram for parabola and the equation is y equals to x square. This is the standard curve. Like we all know that this is the circle, this is the standard diagram, and the equation is x square plus y square equals to r square, right? Like that, this parabola is the standard curve and this is the standard equation for parabola, right? Then the equation y equals to x. This is again a standard equation. It is a line which passes through the origin in that way. So this line is y equals to x and this is the parabola y equals to x square. Now if I want to integrate first with respect to y, that means I need to draw a strip parallel to y axis. This one is y axis and this one is x axis. This strip starts with the parabola, that means the lower limit of y is x square, and this strip ends at this line, so the upper limit of y is x. Now this is the origin. We know that the intersection point is 0, 0. I want to know this intersection point. I have two equations, y equals to x and y equals to x square. Just substitute the value of y in this equation. Y equals to x, substitute it in here. So x is equals to x square. Right? So x is 1. And x is equals to y, that means this point is 1 and 1. This point is 0, 0, this point is 1 and 1. So the limit of x is 0 to 1. Clear?
Yeah, ma'am, it's clear. Thank you. Thank you so much.
Thank you. Thank you. Any other doubt?
No, ma'am. Thank you.
No, I'm asking to other students as well. If anyone are having doubt, they can raise your hand. Anyways, let's move towards the next question. In this question, you can also do one thing. If initially you decide that you want to integrate with respect to x, I don't know, I hope you will not get confused. If I want to integrate this question x plus y first with respect to x and then with respect to y, what I'll do, I'll draw a strip parallel to x axis. right? Now this strip start with the line y equals to x. So the limit of x will be, lower limit of x will be y, and the upper limit of x will be x equals to root y, right? And the values of y, again the intersection point is 0, 0 and 1, 1. So the limit of y will be 0 to 1, right? And after integration we will get the same answer. Again in this question limits are given, so it is easy for us to integrate it, but here also I need to explain one thing. The question is 0 to 1, 0 to y square e raised to xy dy dx. If you simply draw this bracket and you first integrate with respect to y, apply this limits, then you will integrate with respect to x, what will be, okay fine, let's do this in that manner. So the integration of e raised to x by y is e raised to x by y, and for x by y I'll divide with minus x by y square, and the limit is 0 to y square and dx. What I am doing, I am applying the limit of y. So the limit of y is upper limit right? Am I clear? यहाँ तक ठीक है? Yes, Pooja, you want to ask something again?
No, ma'am.
Okay. So this one is correct? This one is correct? No. This is not correct. This is wrong. Why it is wrong? What I have done here? Why it is wrong? So let's remember one more concept in double integration. If the limit, this internal limit is in the form of y variable, right? Y, it is y square na, that means this limit is in the form of y variable. That means it is a limit of x, right? And definitely the remaining will be limit of y. Clear? Let's say if we have a question 0 to 1, 0 to x square, and we have any function, I am not writing here the function, whatever the function is, dx dy. I am not bothered about this sequence, whatever is written over there, whether it is dx dy or dy dx. You need to decide the sequence through this limit. This limit is in the term of x. That means it is limit of y variable. This is in the term of y, that means it is limit of x. And the outer limit, definitely it will be in constant term. In every question, the outer limit will be constant. 0 to 1 or 0 to pi or 1 to 2 or whatever. The outer limit will also be in constant form, and the internal limit can be in constant terms and or can be in variable form. Clear? If it is in variable form, then you need to think, if it is in x variable, then it is a limit of y variable. If the internal limit is in the y variable form, that means it is a limit of x variable. Am I clear? Is any doubt in this concept of limit? Clear now? Fine. So I think now you can get what I have done wrong over there. It is the limit is in y variable form. That means it is a limit of x variable. That means I need to integrate first with respect to x and then with respect to y. So you need to integrate with respect to x first, right? And after integration and applying the limit, you can apply the integration with respect to y and then apply the limits of y. Clear? Am I clear? Again, we have a question. We need to find this double integral, but limit is not given. The hint is given for the limit, that is positive quadrant of the circle. So we know that this is the circle and the first quadrant, this one is the first quadrant. It is known as positive quadrant always. That means this part is the region in which we need to find the integration. We just zoomed out this part over there. Clear? Then first of all, I need to decide for which variable I want to integrate first. Let's say I want to integrate first with respect to y, right? That means I need to draw a strip which is parallel to y-axis. These are the strips that I have drawn over there, which is parallel to y-axis. This strip starts with y equals to 0. This is the x-axis now. So equation of x-axis is y equals to 0. And the equation of circle is x square plus y square equals to 1. So the value of y is root 1 minus x square, right? So this strip start with x-axis and end at the circumference of the circle. So this equation of circle is y equals to root 1 minus x square, which is the upper limit of y. Clear? Then the limit of x, this point is 0 and at that point the radius of the circle is 1. So the value of x at that point will be 1. Limit of x is 0 to 1 and limit of y is 0 to root 1 minus x square. Then we simply integrate it and find the double integration. Clear?
Yes, ma'am, we can conclude. Thank you, ma'am. Such an informative session. Thank you, learners. And if still you have any doubt, then you can please send it over to the discussion board. We will answer it there. Okay. Stay safe, stay healthy. Goodbye, everyone.